This is Algebra 2 Final Review Notes, Part 2. We're going to jump to Unit number 4 now. Unit 4 was our solving quadratics. Remember, quadratic is anything with something squared in it, and graphing parabolas. We spent a lot of time on this also in the last unit, graphing different types of stuff using our zero product property. One of the ones I want to start with is examples like this. This is always one of the trickier ones. So if this was set equal to 0, I could just set these equal to 0, but it's not. So what I have to do is factor it after I get it set equal to 0. So I have to FOIL this out. Minus 4x plus 6x minus 24 equals 11. Subtract 11 to both sides. Go and combine like terms here. And I'm looking at 2x equals negative 35. Okay. Now it's set equal to 0. Now I can actually factor it. Use my zero product property. 7 and 5, they add to a positive, so the bigger one's positive. So I set those equal to 0. And we're looking at x equals 5 and x equals negative 7. Let's go ahead and take a look at a parabola. Okay. So when it comes to parabolas, they ask for a couple things. Let's look at this question right here. They're going to ask for the line of symmetry. They're going to ask for the vertex, the domain, and the domain is all reals. We should know that one. But let's go ahead and start with the line of symmetry. Line of symmetry is equal to x equals negative b over 2a. Okay. So I'm going to go ahead and say, alright, so remember this is a, b, and c. So my line of symmetry is x equals negative 8 all over 2 times 1, which equals negative 4. Okay. So that is my line of symmetry. X equals negative 4. Now to find my vertex, you remember I have to take this, plug it back in here because the vertex is an x and a y. I know what x is, plug it into here and find y. So it's going to be negative 4 squared plus 8 times negative 4 plus 2. We're looking at 16 plus negative 32 plus 2. That's negative 16 plus 2, and that's negative 14. So my actual vertex, I haven't really answered it yet, is negative 4, negative 14. All right? And that's a point. So I kind of box the actual answers. Line of symmetry and vertex. Domain is all reals. Let's look at a max or a min. Well, going back to the original parabola, it has a positive leading coefficient, so that means the parabola is going to open up, okay? Meaning it has a minimum, and the minimum is always the y-coordinate of the vertex. So this has a minimum, okay? And the minimum equals negative 14. All right. Let's look at one that is in the HK form. Find some of that same information. Y equals 1/4 x times x plus 2, quantity squared minus 5. This is in the HK or vertex form, and if you remember, so now my line of symmetry is equal to my x coordinate. Remember, the ones inside the parentheses are always changing the sign, so it's negative 2. The vertex is negative 2, negative 5. All right, we only change the sign for the x coordinate. This is also has a leading coefficient that's positive, so this one opens up. This one would be wide because it is a fraction. And the minimum value, okay, is always the y coordinate, and the minimum value equals negative 5. Okay. One of the, and then let's actually graph this one or kind of get a picture of it. So when I graph this, I go to the vertex, which is -2, -5, 1, 2, 3, 4, 5. It's right there. It opens up. This one's a little bit wider because of that, because of the fraction. And the sketch would look something like, oops, not a very good looking parabola. Would look something like that. Okay. You also had some consecutive integers in here, and remember, I'll just kind of get you started with this. Consecutive integers, okay, that's always x and then x plus 1 and then x plus 2 and so on. Consecutive even or odd, remember it's the same thing, it's always x, x plus 2, and x plus 4. There was a couple word problems in here involving parabolas. Remember, all of that relates to the vertex. No matter what happens, always relate to the vertex. Going back to parabolas, there's also the idea of shifting or translating. So if they give you this parabola right here, y equals 4x squared, and they tell you it has a new vertex of -5, 7, okay, a new vertex, could you rewrite it? And remember, the HK form is y equals a times x minus h plus k. And so in the one above here, in this one here, the actual equation is 4 times x minus 0 squared plus 0. So I'd have to plug this number in there and this number in there. And so the actual answer for this one will be y equals 4 times x plus 5, remember the sign changes inside, squared minus 7. Okay, minus 7. Alright, and then the last one we'll look at is some stuff from 5. Chapter 5 was our unit on complex numbers or imaginary numbers. Remember that looking at this is I is always equal to the square root of -1. Okay, and so we had different types of questions we had to do here with roots and conjugates. So to kind of do a few examples here, if I had something like 4 over 2 plus 7 or root 7, okay, and they asked you to simplify this, you'd have to use the conjugate. Remember, you'd multiply by to the top and the bottom. Remember, conjugates are the same numbers, but only the middle sign switches. You'd have to distribute to the top, and you're looking at 8 minus 4 root 7. Down here we got 2 times 2, which is 4, minus 2 root 7, plus 2 root 7, minus, because it's the negative times the positive, times root 7 squared. And remember, the whole point of using a conjugate is get rid of all the radicals in the denominator, which we call rationalizing. And we're looking at 8 minus 4 root 7 all over 4. These are opposites, and then it's minus 7, and then the actual answer is 8 minus 4 root 7 all over -3. Okay, we had to do that with some I stuff. For example, 4 plus 3i all over 2 minus I. So it's the same, we've got to use a conjugate, so I'm going to multiply by 2 plus I all over 2 plus I. I got a FOIL on the top and the bottom. Okay, so I'm going 2 times 2 is 8, plus 4i, plus 6i, plus 3i squared. Down below I'm looking at 4 minus 2i plus 2i minus I squared. Okay, remember this I squared, kind of think of it like that. and we're looking at 8 plus 10i plus 3 times -1. Remember, I squared is -1, all over 4, these are opposites, minus -1. So it's trying to be plus -1. So now we're looking at, this is going to be -3, and this is going to be plus. So we're looking at 5 plus 10i all over 5. And remember, you need to write this in the complex form, so it's going to be 5 over 5 plus 10i over 5, and then the answer is 1 plus 2i. It's our final answer there. Okay. We had some solving equations like this that were in this unit. Some of the things that we got to look at are, for example, things like this. 4 plus x plus 3 squared equals -24. I'm going to isolate the squared here. And I'm looking at x plus 3 squared equals -6. I'm going to take the square root of both sides. X plus 3 equals I root 6. We're going to take the negative out. And then I'm going to subtract 3 to both sides. Alright, and this is, sorry, technically plus or minus. And then x equals -3 plus or minus I root 6. We also had some completing the square questions. So if I had x squared plus 8x plus 2 equals 0. In order to complete the square, you got to subtract 2 to both sides, getting the 2 squared, or the 2 terms with the x's alone. And we're going to leave a space, and then leave a space. And how do you find that number? It's b over 2 squared. So we're looking at 8 over 2 squared is 4 squared. So I'm going to add a 16 to both sides. And this turns out to be x plus 4 equals 14. Now I take the square root of both sides, and I get x plus 4 equals plus or minus the square root of 14. Subtract 4 to both sides, and x equals -4 plus or minus the square root of 14. Okay. We also had some quadratic equation in there, which we should remember know how to do that. And there we go. These videos will be posted on my website. Email me if you have any additional questions.